Fernando is going to talk to us about evapotranspiration. Yeah, and what is the impact of impounding hydropower? Is it hidden positive or negative impact? Yeah, let's hear him out. Yeah.
Okay, thank you very much. Okay, so my name is Fernando Jaramillo, and I come from the Department of Physical Geography at Stockholm University, Sweden. Although you can tell by my Swedish accent that I'm not really from Sweden. I'm from Colombia. So I'm a hydrologist, and I just want to go a little bit through a story that we've been doing research for the last 10 years. So basically, it's trying to understand effects from hydropower and regulation that are not evident, or the typical effects that most scientists and stakeholders are working on. So, for instance, here you see the typical map. Now, this is the real study of connectivity in water in rivers worldwide. So there's a lot that is being said about connectivity and flow fragmentation and bypassing of rivers, but that's commonly and its relationship to aquatic ecosystems. But there's actually more hidden effects of hydropower and flow regulation that we really don't know about. I think there's something with my thumb. Okay. No? Okay. It's not the first time it happens, so it's really something with my thumb. I don't know. But so I'll just bring you back to this study that we did almost, time flies, already 10 years ago, and it was in Sweden, and the idea was to try to see if we could recognize effects or signals from regulation. So we worked with the 10 largest hydrological basins in Sweden, which here you see on the left. And we tried to assess if these basins were mostly affected by hydropower and regulation, or mostly affected by agriculture, or they were not affected at all. So you see here, for instance, the red basins are basins that are heavily affected by hydropower and regulation, mostly in the north, and then in the south you have the hydrological basins that are mostly affected by rain-fed agriculture. But here, so we started trying this. Why did we choose these basins? Because they're the basins with the largest historical record of hydrology. One thing of being in Sweden is, which is nice, is Swedes have really kept historical records of water changes for more than a century. So you can actually track water changes back to the beginning of the 20th century in all of these hydrological basins. So this is the example of the Dalälven, which is located here. And then we wanted to see if we could find any effects of this accumulation of hydropower and accumulation of regulation. So here, this is the time series of the entire 20th century. Here you see this pink line is the accumulation of installed capacity of hydropower generation. So you see that it has increased through the 20th century. And then on the green, oops, me again with this thing. Yeah. On the green, we see the variability of downstream runoff. So what does it mean that this line is going downwards? Well, of course, that the more that you install dams or the more you regulate a river, you're suppressing the minimum and maximum peaks of that flow. So that's why you see that the variability between daily runoff, or the water that is flowing in the river, it's decreasing with time. And that is what we're expecting of regulation a bit, right? And this has been seen in many hydrological basins around the world. But what caught our attention was this purple line. So this purple line is actually evaporation coming from the hydrological basin. or in relation to precipitation, which is the amount of water that falls into this hydrological basin. And you can see that throughout the 20th century, you start having an increase in evaporation, and then more or less it falls down again, but this is quite remarkable. So there has been an increase in evaporation in this basin that we really don't know why it is happening, right? So then we thought, okay, well, and this actually happened in all of these regulated basins across Sweden. So then we came with the thought, okay, well, why don't we check and see this worldwide? So we took this study by Nilsson, also in Sweden, in Umeå. So they categorized all the basins around the world in the impact of regulation. So the red basins are the basins in the world that have been mostly affected by river regulation. The ones that are yellow are moderately affected, and the ones that are green are mostly pristine or not affected by flow regulation. So we wanted to see if we could find an effect of flow of regulation also at the global scale. So these are the basins that we chose from the global study. We chose the 100 large basins that have the best hydrological data to repeat the same analysis, which are these ones. So red, again, very affected by regulation, yellow, moderately affected, and blue, non-affected by regulation. And this is what we found. Okay. Okay, so again, what we did is that we saw first, the one that you're seeing here on the right, is actually the variation of runoff from the first half of the 20th century to the second half of the 20th century. And you see this per group. So you see that indeed, in all these basins, the basins that are very affected by regulation, there has been a suppression of the peaks. So the flow has been very homogenized with time. So instead of having these natural rivers that we were having with some days with a lot of water and other days with very little water, now we're always having almost the same amount of water. That's why you see a decrease in the variability of runoff. But what was very interesting was actually we saw the same effect that we found in Sweden, that this is, again, evaporation over precipitation, the change from the first half of the 20th century to the second half and beyond of the 20th century. And we see again that the only group of basins that have found an increase in evaporation are the strongly affected basins, which is very strange. First of all, why is this important? Because water consumption is actually an increase of evaporation. That's when we consume water, we are increasing evaporation because of our activity. So if we think that irrigation is a high-consuming activity of humans, well, it is because of that, because we're spreading water in a field, and these crops that belong to us are evaporating that water to grow. So that's consumption. So actually, it looks like by dams, we are increasing human consumption of water. But the interesting thing is this, that we do this analysis in our hydrological basins. This is what hydrologists do. It is very simple. So evaporation equals the water that's coming in a hydrological basin, which is precipitation, minus the water that's coming out, which is runoff, and minus a change in storage. Whoa, okay. Me and this, what is this? The other way. Okay, yeah. So imagine how can we have an effect of dams if dams are just little points in a hydrological basin as big as the ones that we've studied. So it's very interesting to find that we're getting this signal just from the dams, from the accumulation of water. Yeah. So this brings to two hypotheses. So we said, why can this be possible? Well, first, because basins are increasing evaporation in some way, and second, there must be water hiding somewhere around these basins that we don't understand. So the first case, trying to see how are we increasing evaporation around around the reservoirs might be like an increase in evaporation because vegetation is increasing because of all this accumulation of water. And that's what we try to do in China with some tree ring data. So we try to see how trees were growing before and after the impoundment of a reservoir. And this is what we found. Sorry, the levels are inverted, but here you see this is from 1982 to 2014, and this is the impoundment of this reservoir in South China. And you see that the tree ring width immediately after the dam is constructed and the water is impounded, there is a big bubble of increase in tree growth. So that might be an explanation of this increase in evaporation, and this is not seen in the control basins. And then the second case that we wanted to see is if there's water being accumulated around the reservoir. So for this, we took the study of Lake Mead in the United States, which has seen a sharp drop in water levels. So we wanted to see if the change in water levels actually reflects on the change of the surface around the reservoir. So this is what we're showing here. So if you expect more water in a basin, you would imagine that all the land around it bloats, so the level of the surface would increase. But then if you're decreasing the water on a reservoir, the land would sink a little bit. So that's what we try to test by using synthetic aperture radar, so space observations. And here you see this reservoir, and you see actually the blue areas are areas that are sinking is exactly when the water level in the reservoir is decreasing. So this was trying to see if we can understand this explanation of these water changes that we really cannot explain just by pure hydrology. So in conclusion, this is very important. Why? Because then it shows that there's an increase in water consumption that we don't understand. So we found that on this global study, this actually increases the water footprint of humans by 11%. Yeah. And then also, this is the sustainability framework of the safe operating space of humanity. So there's one of the planetary boundaries is fresh water. So instead of having a green planetary boundary, we would have something like this, which is a planetary boundary that is already transgressed by water consumption, just by this hidden effect of dams. So yeah, these are the conclusions, and these are the acknowledgements for the studies. Thanks.